All right, so now we're going to do some problems where we are working with the normal curve, and we're going to see if we can figure out how to work these problems all the way down. So we're given a normally distributed population with the population mean equal to, let's say, 45.3, and the standard deviation is 6.1. And so we're asked to find the probability that a data value from the population is going to be less than 57. All right, so given a normally distributed population, the mean is 45.3 and standard deviation is 6.1. Our task is to find the probability that a data value taken from the population is going to be less than 57. So we are given a normally distributed population. It has a center, it has a data scale, and it has a standard scale. Now we know where this is centered. We know it's centered at the mean, so we know that mu is equal to 45.3, and we know the standard deviation is given to be 6.1. And our task is to find the probability that we have a value on the x scale, finding an x value, such that the probability of being less than that number is 57. So 57 is our number on the x scale. So here's 45. All we know is 57 is greater than that. Again, don't worry about precisely how far away to make it, just make an approximation. So if this is 57, we want the probability of finding a data value that is less than 57. Well, the data values that are less than 57 would comprise these values, all the values less than 57. That would be this, again, very officially named squiggly line, everything to the left of 57. That would correspond to finding the area of this region which is above the squiggly line. Remember that whenever we draw this vertical line, you always draw this arrow to the left. The arrow always goes to the left. No matter what we have in the problem, no matter what numbers we're working with, this arrow always goes to the left. And we want the probability that x is less than 57. The values in this region correspond to that area of the normal curve. So our task now is to find that surface area. All right, so step number one is we need to translate from the data scale x to the standard scale z. Translate from 57 up to this scale, the z scale, and we know the translation form. We know that z is equal to x minus mu over sigma, where we know the x value in question is 57, minus mean, the population mean is 45.3, divided by the standard deviation we know to be 6.1, and compute. Well, that's not particularly challenging. It's to take your calculator. 57 minus 45.3 equals, I have 11.7, divide that by 6.1, and my value is 1.9180. So we have approximately 1.9180. Remember, our rule is to round to 2 decimal places. So we're going to be using an approximation of 1.92 for our z-score. Our z-score is 1.92. I'm going to place that here. So the z-score we're using is 1.92. We want the probability of all the area to the left of that. So now, he said, running out of the room and running back with his normal table, we need to find the normal table value for 1.92. 1.9, that's positive 1.9. 1.92, my table value is 0.9726 0.9726 is 0.9726. Remember, the table value, 0.9726, is the number that goes on the arrow, 0.9726. That value corresponds to the area lying to the left of 57, lying to the left of 1.92, lying to the left of this line. Since that's the value we're looking for the value of everything less than 57. This matches the region we're looking for, and so that's our final result. The probability that x is less than 57 is given by 0.9726.